So far we have completed both the basic types of corrosion, that is chemical type and electrochemical type, and from today we will be discussing on different types, different kind of examples which are often found in many part of the industry. And let us start with the most common one, that is your galvanic type of corrosion. Actually, when two different metals are connected electrically in presence of a suitable electrolyte, the metal standing above in the electrochemical series will become anode, while the second one will your cathode. So because of the presence of suitable electrolyte, the circuit will be completed. Now, depending on the nature of the environment, as we have seen earlier, if the environment is acidic, the further reaction will proceed according to the evolution or release of hydrogen type mechanism, or if the environment is basic or neutral, absorption of oxygen type mechanism will follow and further corrosion will proceed. One thing I would like to tell you, sometimes it is also possible a particular metallic structure made of a particular metal may have some kind of impurities. In that case, the metal standing higher in electrochemical series, if it is the bulk metal or the impurity, will become your anode, making second one cathode, and in presence of a suitable electrolyte, circuit will be completed, and depending on the nature of environment, reaction will proceed either by following release of hydrogen type mechanism or absorption of oxygen type mechanism. So let us take a simple example. Suppose this is a galvanic cell. This is your zinc rod. Zinc sulfate solution will be there. And this is your copper rod. Copper sulfate solution will be there. Now if it is connected, and this is your, this is your what? Salt bleach. Now, since zinc stands higher in the electrochemical series, therefore zinc rod will become your anode, copper will become your cathode, and reaction will, at anode reaction will proceed like that. Two electron will be released, producing 2 zinc plus, and this is your E minus. It will move like that. That is, electron will move from zinc to copper. So this type of corrosion, where two different types of metal but different kind of metals are involved, and one stands higher than the other in the electrochemical series, will become your anode, making second one cathode, and corrosion of this type is known as galvanic type of corrosion. The most common example of galvanic type of corrosion is steel pipe connected to copper plumbing. So here you can easily understand, iron being at a higher position in electrochemical series, in this situation, iron will become your anode, copper will become cathode, and automatically a electrochemical cell will be produced in presence of suitable electrolyte, maybe moisture or any other solution used in different industry. If it is acidic, reaction will proceed following the mechanism, that is release of hydrogen type, and if it is basic or neutral, so it will proceed following the mechanism involved in absorption of oxygen type. This is all about your galvanic type. But the basic principle is that two different metals will be connected electrically in presence of a suitable electrolyte, and the metal standing higher in the electrochemical series will become your anode, making second one your cathode, and under suitable condition that is under in presence of suitable electrolyte, reaction will proceed. Oxidation will take place at anode, and at cathode, reduction will take place. This is how corrosion takes place in case of galvanic cell. Now we will be taking our second example, that is your stress corrosion, which is very, very dangerous and very much common. Start the second one, that is stress corrosion. And to my mind, stress, the word itself represents what does it mean. Stress corrosion is perhaps the most dangerous and very important in many fields, including your civil structure. We make different type of structure which are very stable in inert situation, but start corroding in actually corrosive environment due to external stress. Now we have to see how many types of stresses are there. Actually, this stress may be of two types. Number one is tensile stress or residual stress or externally supplied stress. So you can easily understand what is externally supplied by applied stress. If any kind of stress is applied from outside, it is known as externally applied stress. Most importantly, tensile or residual stress is very, very important. In one of our previous lecture, I have discussed and given you some idea of what is actually residual stress but tensile stress. Let me discuss little more about that. But the entire phenomena I will discuss when I will be talking on intergranular type of corrosion, which is very relevant and related to tensile stress. You might be knowing that during casting of iron in blast furnace, we generally allow molten iron to pass through a particular die. For making you understand, let me assume there are three layers: external layer, adjacent layer, and innermost layer. Now, during the time the molten metal starts solidification, which is very, very important, because during this period metal develops its all mechanical and physical properties. If we do not control the temperature, if external layer takes 1 hour to solidify, the adjacent layer will definitely take 1 hour 15 minutes. And innermost layer will take at least 1 hour 30 minutes. It means the rod we have prepared is having three types of qualities. The innermost layer will be very, very sensitive in nature, and outermost will be the strongest one. Under suitable situation, the innermost layer will become your anode, because this area is very, very stressed, weak area. So this kind of stress is known as your tensile stress. Sometimes it may also happen some metallic structure has undergone some kind of welding. So actually residual strength but tensile strength of the stress which remains after forming or after welding. This is known as actually tensile stress. Therefore, if any metal or metallic structure has this kind of stress, and under suitable condition, let me tell you, essential condition for stress corrosion, essential conditions are either of these two. You must have either tensile stress or external applied stress and corrosive environment. Suppose it is a metallic structure. Now you can see, generally stressed area will be where there will be bend or joint, and therefore this part will be under stress. Under suitable condition, this part will become your anode and remaining part will become your cathode, and under, depending on the nature of the environment, electrochemical cell will be produced, and in presence of suitable electrolyte, corrosion will proceed accordingly. Actually, this kind of stress corrosion is extremely dangerous because initially you will not get any kind of indication. Suddenly there will be a fracture causing a catastrophic failure. This type of corrosion is actually often found in fabricated articles of certain kind of alloy like zinc brass or nickel brass, due to stress, and the stress being generated due to heavy working like rolling, drawing, and insufficient aniline. The word aniline, you have to understand that it refers to ununiform cooling, what we have seen earlier during casting of iron. If the rod has three different layers is coming down to the room temperature at different time. This is called aniline, improper aniline, and because of this kind of things, stress corrosion will take place. But one thing I would like to tell you, if your metal is absolutely pure, it will be stress-free. There will be no chance of stress corrosion. The most common example for stress corrosion are scission cracking and caustic embrittlement, which I will discuss in the next lecture. And if anybody asks you how we can go for protection of stress corrosion, the best option is we have to minimize at any cost the amount of stress in the article when it is being placed in a corrosive environment. I hope you might have understood whatever we have discussed today. Please go through the video very carefully. If there is any doubt in your mind, please get it noted. And during our lecture, I will try to clarify your doubts. And in the next video, I will be sending you both the examples, scission cracking and caustic embrittlement.